we'll go in a little bit of my background, but anybody here research IoT at all? The mobile aspect, hardware aspect? Hardware hackers, anybody? Hardware hackers? Few? How about web? Anybody experts in web? Okay. Got a good mix. Firmware, embedded, anybody have? Same guys, cool. Awesome. So my name is Aaron Guzman. Scripting XSS is my Twitter name, a handle. I'll go ahead and tweet out the slides afterwards. I was a technical editor for Practical IoT Security, a book that just came out in June via Packet Publishing, as well as a leader for the OWASP Embedded Application Security Project, and a contributor for Cloud Security Alliance IoT Working Group. We have a lot of documentation and guidance and so forth. So I'm based out in Los Angeles. I work for SecureWorks. We have a lot of our team here sitting in this room. I'm a board member for OWASP Los Angeles as well, and the president for Cloud Security Alliance of Southern California. So you guys are ever in the area, let's say for OWASP, we have an AppSec California conference the last week of January, right on Santa Monica Beach. So if you guys want to move from the East Coast to the West Coast, great conference to be at. If anybody wants to volunteer, hit me up. I manage the volunteers at the conference. There's a little book right in the corner. It's a pretty good book. Literally, like I said, just came out not too long ago. Everything from how to securely design and deploy an IoT device from consumers to enterprise to ICS environments and very highly regulated environments as well. Even to connected cars and vehicles, which we'll get into as well. So we're going to start with what IoT is today, and much of it is what you've seen as in wearables with keeping track of children. You also have your coffee machines, your crock pots that are connected to your, whether it's a web dashboard or an application. You also have thermometers that check whether a piece of meat is ready to be cooked or is it not, is it old, as well as devices to measure your water consumption for your household, as well as industrial manufacturers as well. So what this does is basically it measures, a lot of machine learning is also obviously involved with big data with all of these devices, but with manufacturers, they kind of try to put things in line for your water. There's one called HydroPoint, is one of the manufacturers there. A lot of irrigation and farm systems, which are already being deployed and being used by people who manage these different ranches and farms and irrigation systems, as well as making a regular car smart by connecting it to the network, whether it be GSM, satellite, or some sort of wireless technology within a city. Another example of this would be Nest. You can connect an exact, I don't know if you guys can see it there. I wish I could point it out, but it plugs into your power, and you could configure Nest to automate when you're on your way home, however far you want to set your AC to turn on, as one example. So it connects to like Mercedes-Benz and other manufacturers. For what reason, I don't know, but that's just another example of what's out there today. And what's out there tomorrow, as far as Internet of Things of the future, not her, but she's in it. Smart cities. Definitely smart cities are up there. Singapore is one of them. They have a huge amount of sensors, of solar power, of connected devices, and actually one of the main cities that has a lot of data points, and the government basically doesn't have any public, let's say, open public discussions about deploying this. They kind of just do it by their own discretion as far as Singapore is concerned. So when you have that, you have a different type of long-range wireless network within the whole city, as well as everything else connected between sensors, whether that be lights, whether that be smart buildings as well. Those are all into place. So Singapore is one example, and I know Korea, North Korea, did I say that right? is another example of that. But again, a lot of huge threats there with sensors. Again, embedded devices, wireless technologies, and what I've heard, I know Chicago has a lot of they're betaing a lot of wireless sensor technology within the city to manage and predict different weather patterns. And they're doing that via GSM. So when you're designing these products, GSM obviously has some inherent vulnerabilities. Whether you choose another type of technology as well, Zigbee, Z-Wave, we'll get into those later on, but each of them have their own items of security to keep in mind when designing. But again, it's going to be basically a playground for us as researchers, hackers, and hobbyists to kind of get in and mess with these things legally, of course. So you also have connected cars, whether it be autonomous connected vehicles, whether it's Uber, Lyft, any of those Zipcar. I know Uber and I think it's Uber and Pittsburgh in level 3 communications. They're working on autonomous vehicles picking up passengers without any driver there. So that's pretty interesting, pretty crazy. And of course, a lot of research is in this area. I'll get to that in a second. But with connected cars, connected vehicles, you have vehicle-to-vehicle communication, vehicle-to-infrastructure, and vehicle-to-application, V2X. All of those are different attack surfaces, attack areas, and expertise, whatever, like I said, you're a hardware hacker, you like doing application pen testing, or researching. You can basically choose what you want to attack here and find something almost guaranteed from what I've seen. And I'll demo something I found in my car later on, and don't even have to be sitting in my car or around my car to exploit it. But again, other car hacks, just one that happened this week was with Tesla. A little bit of an interesting situation, but the car basically had to connect to an unknown or a malicious access point in order to exploit the vulnerabilities that were discovered, but still fixed by Tesla. But again, you're going to see more and more of this, whether it's Tesla, other car manufacturers. I know Volkswagen just opened up their own cybersecurity team for connected vehicle research specifically. So again, lots to come here in the future, and it's happening within the past week, and it's going to keep happening. So the other crazy things that are going on is the medical field having like bionic arms literally being deployed already. Imagine if you don't pay your medical bill and you have to get your arm repossessed. That'd be pretty interesting. You have implantables go directly in your body. We already know about insulin pumps, things like that, wireless technology. Sometimes it's Bluetooth, sometimes it's magnetic, sometimes it's even via Wi-Fi. Then you have different types of networks being deployed, and one of the big players in the game is Cisco, and they're coining this term fog computing. So the way networks are being deployed now are basically almost like sensor nets, and it's not your typical kind of stadium deployment of your network devices, but more so a way where you can try to find a way to monitor these devices because they're being doubled actually, within the network. You have such small devices, and again, sensors. They could be within. I'm going to say it's more of a manufacturing way. In each line, as far as building something, and they all connect to some sort of controller or some sort of gateway. But you have to have a way to monitor that, which you'll have, let's say, new security vendors like Senrio who are trying to accomplish this and aggregate that data, what devices talking to what domains, how often, and also not sticking to Senrio, but as other vendors are trying to do is manage the updates and the firmware of what each device actually runs, because that's a big problem, right? Sideloading firmware, running untrusted firmware on any of these sensors or embedded devices. So just to go over a bit of a case study, Pony Express released the Internet of Evil Things report. And to sum it up, basically, we're not ready to manage or monitor these RF frequencies. And this one is RF and off-network IoT devices. 89% cannot see Bluetooth devices. 87% cannot monitor 4G LTE devices. And 71% cannot detect off-network Wi-Fi devices in real time. 56% cannot not even monitor on-network IoT devices in real time. So anything that's plugged into your network in the enterprise, or anything that's Bluetooth. I know a couple cameras that I just bought. They speak via Bluetooth, and you have like a wireless gateway. But you can have 20 cameras connected to one gateway. That's 20 extra devices that, as a security or as a enterprise, totally unaware of what's going on, what they're doing. And again, you can't even manage those assets because Right now, we just don't have the capability to, or the technology is moving so fast. So OpenDNS also released one, I think about in December, and it was a survey of 500 security professionals, and they found that 23% have no mitigated controls in place to prevent someone from connecting unauthorized devices to their company's network. So you guys seen this with smart TVs, probably some light bulbs, or doing some research, or connecting a router that you can access remotely, because now routers are IoT devices too. Anything that kind of has a mobile application that is networkly connected and you can configure it remotely. These are all these types of devices that are being brought in from consumer homes over to the enterprise. And again, the capability to monitor these things aren't there yet, or I guess I should say the security teams aren't, up to par just yet. So kind of a big area that's being missed, and obviously wireless technology is one of them. So I'll speak to as to why, but with these case studies, it's basically saying, oh no, bad, we're not ready to do this, we're not ready to do that. But I'll give you one last one before we go into the good parts. And you guys probably already know this as security professionals, but a lot of PII data, privacy data, information being collected about you as an individual, as a home, what's in your network is being collected for these IoT devices. And from threat posts, they came up with 90%. And then 6 out of 10 devices that provide a user interface are basically susceptible to cross-site scripting and weak credentials. Not a surprise. Probably even remote code execution, from what I've seen. 70% of devices use unencrypted network services. 70% along with their cloud and mobile applications enable an attacker to identify valid user accounts through account enumeration. Very, very simple things, whether it's forgot your password, whether you find it within the mobile application stored in clear text, sent as a header. I always see these devices sending your username as a header, even your token, which we'll get to in a bit. I'll show some examples later on. So speaking to designing these IoT devices, to kind of preface, I used to work at Balkan and Linksys. So I used to lead security for Linksys. Again, they build routers, they build network cameras, and then for Balkan, they have Wemo. We won't get into that, but that's a whole different thing. But building from the beginning to end, and experiencing and trying to plan to develop these devices is a bit of a challenge, because you have hardware design, and with hardware design, you have your PCB and BSP selections, so your drivers, your hardware, your interfaces, and what all that entails is basically money. Who has the lowest, who's selling the lowest Bluetooth, wireless card, wireless controller, wireless chip, the cheapest, and how can we make it work with our product design? And again, peripherals, whether it be you have a USB, you have USB 3.0, and again, with these, with the BSP designer, which are Broadcom Marvell, those guys basically connect, hardware to software. You can talk to the hardware aspect. And with peripherals like USB, you have third-party contractors or developers who are actually creating that. So although let's say you're getting a router, and it has USB 3.0 and also has, network access, for SMB, each of those, the USB driver is a separate contractor. Accessing the SMB shares via the network is also another contractor. So, for example, Linksys, it's not just Linksys creating it. There's like 6 other teams for one device. And same thing with any other type of embedded device, like Android. It's a mess because there's so many people touching the code. There's not a streamlined update process for manufacturers, OEMs, and ODMs. But again, we'll go through some of that. But as far as building these devices, things to keep in mind. So we got from hardware and the selections, but also firmware. And the tool chains with the firmware, whether you're going to load it with the strip BusyBox image, or you're going to use something else that's not a Linux derivative. Let's say real-time operating system is one. And they both have their their own vulnerabilities. But when planning this out during the design stage, again, things to keep in mind. And I spoke to third-party drivers like USB and the trouble that causes. But You also have the mobile applications, and whether you're going to choose a native or a hybrid structure or a way to create your application, both have their pros and their cons depending on the goals. And the frameworks with whatever mobile application or whether you're using Cordova or whether you're using Xamarin, things like that for rapid development, because what IoT, like anything else, is fast to market. So if you can create something fast, and there's plenty of mobile app builders out there that you can drag and drop and just connect it to your device, very, very easy, and that's why there's, it's one of the reasons why there's so many issues going on in the IoT space. But again, we'll go through more of that later. In the web application aspect, I know for Ring Doorbell, you have your Android, iOS app, but you also have a web dashboard too. So those are all different areas of interest. And the web infrastructure behind that, whether they have admin interfaces enabled, updating, patching, things like that if they're using a cloud service provider, whether it be Azure, whether it be AWS, and again, with the security controls and mitigations in place. It's kind of hard to think of new companies who are creating these devices to have expertise in all these areas, let alone, I'm pretty sure not all of us here have 100% comfortability with, either hacking or securing or building an IoT device in any of these areas here. And again, they have their own web frameworks and different languages you can choose from, Ruby, Python, whether you're using Django, and so forth, ASP.NET. So here, to stick to the supply chain, you have your BCP, your ODM, your cloud service provider, and your OEM. So BCP is Marvell. Like I said, Marvell, Broadcom are pretty much the big names. Your ODM, which I tend to find is a small 10-person company in China who just wants to, spit out code and make money. And the OEMs are looking to the ODMs to basically provide an API that they can use and basically slap their name as far as OEMs concerned. They support that. So when you guys hear of vulnerabilities in D-Link and Netgear, and it affects like 20 devices, or even cars now, with the infotainment systems, there's the same OEM that's using and being spanned between all of these devices, and that's why you hear it affects so many. But again, these are third party. Yeah. I'm at ODM right now. I'll stop here. So I'm at ODM. This is original design manufacturer. BCP is board. I can't remember the acronym, but they're basically the driver manufacturers. So driver manufacturers, and these guys, ODMs, are original design manufacturers. These guys create, the software that, or APIs that OEMs use. Say they don't want to create the whole application in-house. And with ODMs, you also have separate teams as well. So you'll have someone in charge of, let's say, turning the lights on, making sure the schedules work, making sure when you turn the app on that all devices are found in the network. So again, this is like so many hands touching it, and they probably subcontract too, this team in China. So you have people from China, from the US, from somewhere around the world, all touching one code base for one product. It's hard enough to keep one web application secure with one team, but let alone one small device and, one app, but spanned across different teams around the world. And let alone the hardware and the supply chain between deploying that. But again, just to speak to it, a little bit difficult to solve this problem when you have a supply chain like this with IoT. So BCP, ODMs, and to connect these devices for remote access, you have to have some sort of cloud. Usually it's AWS, I've seen, that most people are using. So a cloud service provider. And again, you have AWS IoT APIs. You have Azure IoT APIs as well. So these are for remote access. The OEMs, these are the guys who support the product. Any security issues, they kind of get the hit for it. And again, they kind of just put their logo on there and hope for the best and take the media and the PR. But again, kind of a mess. So the end result, you have one of these Ring Doorbell. And I was walking around through a Costco, I was looking what device that I can go and mess with, basically. I gave this talk over at Defcon, IoT Village, and literally the week before, I was like, oh, let me see what I can get. And I look at the Ring doorbell, and it says, encryption, bank grade. I'm like, hell yeah, I'm getting this one. So then I was like, what the heck is bank grade encryption? But again, that's the reason why I picked it. And we'll go into some of the things I found with Ring doorbell. So what we can do as researchers, hackers, security professionals is look at the downfalls and their impacts. Same things with manufacturers. See what's already out there, what's been done, and what's common. And people say hack like it's the 90s. Yeah, misconfigured services for Telnet. I know like the Parrot drone had an open Telnet service listening. You just connect to it and shut it down. And it was like DOS. And I was like, oh, cool. FTP, SSH, anything that's basically old and legacy. It's still being deployed. And again, some of these kernels that are being deployed with these IoT devices are old kernels with vulnerabilities that are already publicly disclosed and are exploitable. You have client-side secrets, whether that be passwords, API keys, OAuth tokens, especially everywhere. OAuth tokens are sprayed. And this could be hard-coded into the firmware or hard-coded into the mobile apps. And also like private keys, whether it's to sign or validate that firmware is a legitimate firmware. But again, if you're storing the private key, there's no point. You're doing it wrong. They have a misunderstanding of signing firmware. TLS issues, and this spans between firmware, the mobile apps, and the server side. Probably number one most common problem that I found, aside from insecure data storage or storing secrets, is misconfigured TLS. And because it's I don't know if it's difficult, but with iOS you have certain configurations. You want to use app transport security, for example. And what that does is connect TLS 1.2 only and Cipher suites that only support FPS, for example. But also the Cipher suites from the server side. And I don't know if these teams are even capable or want to know. They kind of just get the first cheapest certificate that's available and just deploy it. But again, very, very common. And these things are personal, right? These devices, they're being deployed into your house, they're being deployed into your network, and they're gathering everything basically as intelligence or analytics from your network. And for it not to be protected with data in transit, it's kind of a big deal. We talked about insecure data storage already, whether it be cache, whether it be temp, and again, whether it's stored in clear text or dumping in a file within the let's say the mobile devices, sandbox, Android or iOS. Vulnerable frameworks, and I talked about Cordova as one of them. I'm not sure if many of you have heard of that, but you have a lot of big companies who are using Cordova, and it's just basically, think of hybrid applications as web and mobile at the same time. So you have the same web attacks available for a mobile app. And it's all JavaScript heavy. One thing to keep in mind with hybrid frameworks is you don't have to resubmit the application in order to update it, because you own the JavaScript, you own the web portion. So you can do whatever you want. It's easy to become application developer for Apple. Just pay a $100 fee, and there you go, throw your app up there, and update it whenever you want. Pretty simple. But again, these frameworks span between the firmware, the mobile aspect, as well as the web application portion. Messaging vulnerabilities, whether you're using MQTT, CoAP, REST, and SOAP. SOAP is out there. Believe me, it's not great. Hard to protect. No authentication. And then REST, it has its own issues. Whatever the application developers are creating, you have to kind of learn and observe what the REST API is doing. But again, they have their own issues. And again, I talked about insecure updates, whether that's not signing the updates, not encrypting the updates, whether that's in transit, or not validating the hash when the update has downloaded to the device. So one example is Samsung SmartThings. How many people are familiar with OAuth 2? Cool. Kind of. Okay, cool. So with OAuth, you have tokens, right? And when you log into an application, let's say Twitter, Instagram, anything like that, you basically have a long-lived token. You don't log in, you have refresh tokens or access tokens. I'm not sure when the last time you guys logged into Twitter, Instagram, or Facebook, but it's probably been a while. So in order to retrieve an access token with certain authorization flows in OAuth, you'd have to know a client ID and client secret. So what Samsung did is hard code this value into their mobile apps. And in this situation, there was a SmartThings door lock, and someone was able to get access and retrieve access tokens to their door, and will just walk in. And again, I always see these client IDs and client secrets hard-coded into mobile apps. What they can do as an alternative is have the server make that authentication request and pass it back to the client. But again, they want to put everything on the client side for reasons I don't know. But again, one example is letting anybody come into your front door for, again, having the client ID and client secret. Very, very simple. And I'm sure it's the same exact client secret on every single binary that's deployed. Another one I just looked at, I bought this last week. I figured I wanted to throw something extra in there. This is Blink for Home, home security camera application. It's this talks via. This is the one I was speaking to earlier. This camera talks to a little hub via Bluetooth, and then the hub talks to my router and then to the internet. But just analyzing how data is stored once I log in, I can see they store my token in clear text. And my token in clear text is also a brilliant header right here, which never gets expired. Even if I log out for some reason, it still stays there. So I'm going to have to uninstall the app and then reinstall it and see. You can see I'm already messing with it. My network name, wish I could point it out, but I'm always putting script alert everywhere to see how they're filtering. So that's actually my router name. That's not even something that I did inside the app. But anyhow, insecure data storage is one. Long-lived tokens is another. You have the D-Link backdoors with, I don't know if you guys heard, with the user agent. You get admin access, and it's hard-coded into the firmware binary. As you can see there, send that binary, that user agent header. Good, you're good to go. You have admin bypass authentication. Very, very common in a number of different devices, whether it be consumer or ICS, which is, I just took a look at US ICS alerts, and literally the first one I clicked on, I think it's right in the middle. I forgot which one it was here. And of course, it was use of hard-coded passwords inside of the firmware. And again, these are sensitive environments and regulated environments that these things are being deployed on. And again, it says no known public exploits, but I'm pretty sure it's pretty easy to find, and I'm pretty sure it's out there. From the hardware aspect, you have UART, which is basically serial connection. It's the first image there to the left. Once you get access to the UART cables and connections and headers, sometimes, most of the time actually, who am I kidding? It's not password protected. And some other ones have weak passwords, whether it be password 1, password 1, 2, 3, 4. And again, they're always publicly available. You can just Google some of these vendors and the chipset manufacturers, and you'll find what they use for debugging is what they call it, but it's backdoor for me. You have JTAG, which you have full control. Take out the firmware, modify the firmware during real time and runtime. Again, read-write access. EEPROM is that little guy to the right. And a lot of people seem to think that you can hold secrets there. It's not a TPM or a secret element or anything like that, secure element. It's just a little device that has a minimal amount of storage, and all you have to do is put a SOIC clip on top and pull what's in the EEPROM. Very, very easy. And these EEPROM, a lot of devices have them as their, let's say, that make them smart devices. But again, storing secrets in the EEPROM, again, not a good idea, or anything client-side, really. Wireless issues, you have Zigbee, 802.15.4. And they have a default link key, and once you have that, you can get access to all the devices on the network, even Wireshark, it has the decryption key, so you can see all the traffic for all Zigbee devices on the network. So that's cool. Even though all the devices that say they use Zigbee, if you look, it has like a Zigbee certified sticker, and it says they use 128-bit encryption. But that encryption key is in Wireshark already. So again, it doesn't do much. But things to be aware if you're building these type of devices. And Z-Wave has its own inherent vulnerabilities. And it has a key exchange with the home ID and node ID. And again, there's plenty of tools out there to even audit these different wireless technologies. Z-Force is one of them for Z-Wave. Killer Bee is another one for Zigbee. There's many more actually. Many of them are sprouting up because of the adoption and usage. And then Wi-Fi. This one's very, very common. Again, I was talking about Tesla and open access point connecting to it in order to exploit these vulnerabilities. Same thing. Usually with these devices, you'll have to pair them to your network. And how you're going to do that? You connect via your phone and give it the credentials to have network connectivity. So for the Ring doorbell, earlier this year, they had stored the wireless credentials on the doorbell itself, so someone could take it off, pull the network credentials, which is very easy. It just clips on and clips off, and they get access to the network. But now they've since fixed that. But again, having those open and having them default credentials and how they're actually storing those credentials on the devices have been known to show issues in the wild. So demo time. I'm going to demo my car. So what I got, back in February, I was looking for a car. I didn't even know this till after I got the car, but I wanted to see what, found these buttons in there. And I have a Subaru WRX. And I saw I had, when I was looking for the buttons, what they were, I ended up finding that it had a mobile app. And I was like, cool, I'm going to check this out, see what's going on, because I haven't heard anybody looking at Subaru cars. So it's able to, as you can see up there, lock my car door remotely, my vehicle remotely, access my horn, lights, or even locate my vehicle on a map, all from my desktop, tablet, or mobile device. Great, right? So, of course, I'm lazy. What I'm going to do is look at the mobile app, because I could just sit there and not have to go anywhere. I'll show you this one. I sent this exact video over to Subaru. They just fixed it last month, so we're in the clear there. So what I did was I used an iPad that I have, and I pulled the cache database from the application sandbox for the Subaru application. And I dumped what was important to this text file here, but I'm going to show you how I found it. So here's a text file. Not sure if you guys can see, but there is my username there, and there is also a token. And of course, I like tokens, so I'm going to check that out. Mind you, this is all being sent via a GET, not even a POST. So here's the cache database. I'm going to look at it via SQLite browser, see what tables are in there, and I kind of just click around usually when I do these things, see what tables are available. And usually when you see all requests and responses cached, they're probably using a hybrid framework like Cordova. By default, it saves all requests and response. And not only that, with iOS, it's kind of difficult to get around data leakage because you have to set the correct cache headers as well as the cache settings within the iOS application too. So a lot of people get it wrong. So I click in the middle. Usually that's what I do. I'll just click in the middle and show it as text. And again, there's my Subaru account, my username, and my token. So drop that in, URL, my handoff token. Cool, logged in. And what I didn't show here is that services drop down. That's where you can unlock the car door, honk the horn, and do all the fun stuff. But what I was demonstrating here is the insecure use or storage of data, as well as, you'll see in just a second, I'm logging out, right? At least it says log out equals true. It says I'm logged out. Yeah, totally not logged out. So again, I had to censor some things. I don't want you guys to see my home address, but again, you can get things like that, my VIN, start and stop my car, all from the mobile app or the web app in this case as well. So that was fun. Let's check out another one that I had. Let me show you. All right, now I'm going to demo this bank-grade encryption, because you know it's not, right? Let's do, let's go for an Android demo. And again, I'm lazy, I go to the mobile apps. Just want to sit there. What I have running, and it's going to take about 30 seconds here. I'm using a virtual machine called AppUse, and I just pop the APK inside, and I'm proxying via OAuth Zap. And literally, this is just starting the application. And when I start the application, you'll see what it transmits over. About 5 seconds. And actually what it does is it pulls logs directly from the device, like the syslog, and it sends it over. You can also see what it does, well, my user ID, and also, again, my email, my token. That's cool, right? That bank-grade encryption is doing well. But not only that, it gets everything within my network. It sends it over to them. It tells me when I press the Ring doorbell. I'm gonna show that in a bit. But it talks over SIP for UDP 5060. What phones use, and it also uses RTP for video. Some of them are, some of them aren't, and I'll show you in a bit. But I also see this data blob here, and which we'll get back to in a second. Again, my token being sent in the URL as a GET. And again, this isn't in my front door. This is sitting in like my office. I'm not using this like legitimately. But okay, let's go back to this data. To this third-party domain here. Looks like Mixpanel, which is probably an analytics or bug reporting platform. But I didn't accept anything when I started up the app to let me be aware that, hey, this data is being sent to a third party. So again, I see this blob here, and I have a good feeling it's base64 encoded or something, but not quite sure yet. But I've recently been playing with JWT a lot, so I just decided to throw it in there and take out the bad characters, and there we are. It sends, my phone, the version. Obviously, I'm in an emulator. My email, token, what version, Google Play version I'm on, how big my screen is. Again, to a third party. Yeah, exactly. And look at their headers, allow origin everything. So again, grabbing everything, and it's still starting because emulators are slow, right? Yeah, exactly. In my office. Yeah, So, and this blob actually expands. Again, you can see how big it just got because it's gathering other pieces in my network. But I also want to see how the data is being stored on my device. So again, I go through the application sandbox, and you can see I'm highlighting com.ring.app, and it's probably in a preferences file where my token is being stored. Because why not? There it is again, authentication token, and there is my test email that I used. That's pretty bank-grade encryption there. And that's only, this is only how they store data. And I'll show you how they transmit data right here. And this is man in the middling using BetterCap. don't know if you guys used BetterCap before, but I don't know if you guys can see that, but BetterCap. And then using the target as my Ring doorbell, and then redirecting the traffic, HTTP traffic and HTTPS traffic to Zap. So here we are, it's spoofing, doing this man-in-the-middle thing, because I want to see how it's transmitting data. I already see basic auth credentials right away over HTTP. There it is, basic auth. This is from the firmware. So I was doing the mobile app earlier. This is from the firmware. And now looking, shows me the SIP server IP. If it's using TLS, of course it's not. It's false, because it's bank-grade encryption. And it's using Amazon. I can tell by the elastic IP it's using. And here is the SIP server address and the domain. This is all when starting the application. HTTP. Here's another status report that it sends. All over HTTP, basically how long it's been on, how long it's been ringing, when was the last time I rang it, how long it's been connected, are there any DNS issues, any API issues, things like that is all being sent over HTTP. And then enable logging, so we'll show you what the logging looks like right now. It's pretty verbose. Here are the logs. You can tell it's being pulled directly from the firmware there. And again, over basic auth, HTTP. And you'll see there is the IP address to connect to, the SIB client encoded key, base64 encoded again. The port I have to connect to. This is when I'm ringing the doorbell, by the way. And it also opens up a local SIP server on the Ring doorbell. So only when it's ringing is that SIP server enabled. So if you're doing an nmap, when it's not ringing, you won't get the port open, but only when the doorbell is ringing. It's like 30 seconds or something. It's not forever, but you just can keep pressing it. But again, there's the SIP server port and the IP locally, which it's going to connect to because it obviously has to listen and receive. And then streaming, it's saying it's streaming. So again, pulling these directly from the device, all over HTTP and over clear text. And I didn't show it here, but what I was able to do is pipe it over to a soft phone and able to listen. It's all over HTTP. Very, very easy. These are being sold like Walmart, Costco, as an example. So let me get back here. What's that? Yeah, it does show in the logs, actually. That is in the logs, definitely. So when you're securely designing these things, or from the development aspect, you start with requirements from the security team usually, or someone who's security minded. Usually the most important thing is have a secure update ability, as well as some sort of logging mechanisms, whether it be access logs, auth logs, things like that. Following some sort of security process, whether it's BSIM or otherwise. And threat modeling. A lot of these devices, they're being deployed in different areas and also different contexts. So being aware of where these devices can be deployed is a huge, first step. Because how are you going to know your threats? How are you going to know the attacks? How are you going to know the issues if you can't even understand where these devices are being deployed? And again, it's kind of a whole, which leads into security impact, safety impact analysis. So again, these things are, let's say, light bulbs or plugs or your car. Obviously, these are your life. It's your life involved. So doing a safety impact analysis is very, very important from the start. and analyzing the threats and the impact that these, if exploited, that the risk may be for the device and for the manufacturer as well. Sometimes there may be a risk acceptance decision, which it often is, unfortunately, but until there's any type of regulated entity or something like that that enforces these IoT devices, whether it be consumer or enterprise, to abide by, it may or may not happen very soon. Here is an example safety requirement document from ICSA, which is owned by Verizon. And just examples like must not allow transport of non-cryptographically protected private keys via its interfaces. So basic things that you should actually get from the start that, let's say, project managers, program managers don't understand. But again, ICSA Labs has an example document to kind of get started there. A good example of what a device is doing security-wise is Kivo, their quick set lock. So I bought one of these a few weeks ago. I wanted something new to play with. So what it does, again, one of those devices that talks via Bluetooth low energy, but it talks to your phone directly, and it takes the data from your phone to talk to the internet rather than, so you have to be close to it within 30 feet. But right when you install the lock, it forces you to update. There's no going around it. There was already security issues going on with or reported, so you can't get around that, which is good. You know, you can't say later or whatever, but you have to stay there 15 minutes. Says this will take approximately 15 minutes. Please leave your device near your Kivo lock until completed. But of course, I wanted to have remote access to this thing, so I bought the Bluetooth gateway with it, which I'm still looking at. But as an example, they're doing some good things off the bat. They're storing your credentials securely, and the keychain for iOS, and the key store for Android. They're not leaking data. Nothing's being cached. Your geolocation data is not being transmitted anywhere. But again, you can tell they had some security requirements, as they should. It is a door lock. So another step would be implement a secure development integration environment, like IDEs, any like statical analysis or dynamic analysis of tools. If it's not within the workflow of developers, it's not going to happen. It's not going to work. It's not going to be implemented. So deciding between a vendor or a tool that has some sort of API available to the developers, or whether it's within their IDE, is the only way things are going to get done. And again, it's a static analysis. And having some sort of application security pipeline for continuous integration. Again, like scanning builds using Zap, or you could even use Burp. They have REST APIs available. And testing and code quality. Very important. Again, if it's not within the developer's workflow, it's not going to get done. So the different frameworks and platform security features, you have things like AllJoin is backed by Qualcomm. They have their ideas to kind of create one protocol for IoT devices and framework. You have ThingsWorks, HomeKit, obviously only iOS. You have Zigbee. And again, we talked about real-time operating system. You also have Windows 10 IoT or embedded Linux. But again, they all have their own mitigations, vulnerabilities, and their own overhead as well. And even if you're creating your own custom operating systems for these devices, very, very common as well. IoT gateways, these things are interesting. I know one of them is Wink, one of the big ones. We have Revolve that got end of life recently, which is interesting for a consumer device to be end of life. And if there's a security issue with that, there's some arguments between FTC and other entities on enforcing end of life or letting consumers know about end of life. Let's say 10 years, for example, or being aware of that. So let's say for embedded Linux, as far as what I'm trying to get off the ground is the embedded application security project, and this is where manufacturers, developers, security professionals, and there's more to this now. I've kind of expanded on it a bit, but you'll see a lot of buffer overflows in these embedded devices and using known unsafe C functions, for example. But this is where I'm trying to try to have a more of a design and developing guidance for, using OWASP as that vehicle to do that. So look it up. If you guys have any feedback, hit me up as well. We'll jump into privacy, running out of time here. But privacy obviously depends on location, your privacy laws. For us, US, we have FTC. For EU, you have the European Union. The notion is to have privacy by design, meaning taking the minimum amount of data from users as possible. Is that being done? No, but again, that's something that both the EU and the FTC is trying to push. So privacy by design, security by design are the two big notions there. And again, informing users about these privacy policies and third-party applications, domains that are being sent, your data is being sent to. So like I said, Kivo is doing a good job. It's letting me know where and how my location is being used. So again, it tells me it's never transferred or stored to any of our servers. I've verified that on the iOS side of things. But another thing too, with Kivo, you can't use an Android device that's below 5.0. So they exercise certain security features with storing data only with newer devices. The same thing with iOS. You could only use iOS 9.3 and above to use, certain security APIs, data protection APIs. So again, they're doing a good job on that aspect of things. I didn't test the iOS aspect of the application because I don't have Android 5.0 or above. So it's kind of SOL there. You can't see, but this is their info.p list for Kivo. So within the iOS application, I'm not going to go through it too much, but you'll have to define why an application needs certain permissions. And you'll see the long sentences there. They're basically telling Apple as to why they need to use the location 24 hours a day, and then where it's being stored. So some hardware-based controls, using memory control units, system-on-chip selections as well, crypto hardware accelerators, again, things for like ICS, this is relevant to. Tamper protections, tamper detection as well, tamper evidence, whether you're logging on this as well. Something was moved, I know with like HSMs, hardware security modules. Okay. Let me end it here. Way over, sorry guys. APIs always pin. Here we go. Almost there, guys. I'll tweet out the slides, don't worry. Yeah, really behind. Here we go. Ongoing process, defense in depth, security built in. Questions, I have references there. There it is. Thanks, guys. No questions, right? No worries.